Welcome to the third video now of my tips on how to help you with your maths. Today we're going to look at a very A-level specific topic. Going to show you how to use your calculator to help you with trapezium rule. I'm sure you have fond memories of learning trapezium rule. Quite a nice little thing. Get a formula, put numbers into the formula, remember a few kind of key things that perhaps will remind you of in this video, and come out with an answer. Generally students quite like trapezium rule, but that doesn't stop students making mistakes, and today we're going to look at how to use the FX series Casio calculator to help avoid some of those typical mistakes, and actually how to make it a bit quicker, a bit easier. So to do this, all you need is a FX series Casio calculator and a trapezium rule question to work on. We're going to make ours up as we go, because actually it's the same method regardless of what your question is. And once you've used this function a couple of times on your calculator, it's really easy to use. You'll be able to use it fine. So we're going to first of all do something that will make you think that your calculator's broken. We're going to press mode, and we're going to go into mode 3, which hopefully you'll see says table, and it comes up with this screen. Every day someone comes and asks me, Ryan, my calculator's broken, how do I fix my calculator? It's coming up with an FX and I just want to type in some numbers. For once, this is what we want. And what I'm going to do is I'm going to tell it what the function is. Now, the whole reason we use trapezium rule is when we get something that we can't actually integrate. So I'm going to type in something tricky here to make it a bit realistic. So I'm going to look at an exponential function, and it's going to have a trigonometric bit as well. In fact, I'm going to do one that a colleague of mine reminded me of last year. Thanks, Jason. E to the sine x turns out to be a pickle to do much with that one. So trapezium rules are an ideal way of working it out. Let's use it. So type in your function using the alpha and the x key to put in your x in the right place. If you've got a function in terms of t or y, just pretend they're x's, it works the same. Press equals, and we come up with some more options. So start, that's the lower bound where we want to start integrating from. Okay, we're making this up as we go, so let's make up a number. Let's start from 2.5. I don't know why. Next, I have an end value, so where do I want to finish integrating? The question I did before this ended at 5, I'm just going to use that one again, that seems perfectly fine. Step, that's the width of your trapeziums. What width bars do you want to use? Now, the question will tell you this, either directly by saying use trapeziums of width, or it will have a table of values that you fill in. It'll be pretty easy to see what value you want. Now, we're testing our calculator to the max today, so I'm not just going to use intervals of 0.5. I'm going to push the boat out. I'm going to go for 0.25. There it is, 0.25. And calculator takes just a second to think, and then it comes up with this table. Column on the left shows you what number term this is. It has the x value. So we start at 2.5 and then going up and sets at 0.25, and then it has the fx value, what would be the y coordinate to go with it. These would be the values you normally fill in your table. Don't despair. If you look at the first one and it says 1.8193 in this case, across the bottom you have the more accurate decimal, which you may need if they ask for a lengthy number of decimal places in the question you're doing. Or you're just doing a question for fun, but you want to be particularly accurate. So you can go down the bottom. Now, I said this might remind you of a few key things. the biggest mistake I've found over the last few years of teaching A-level maths is that students forget that there's one more bound, there's one more y value for the trapeziums than there are actually trapeziums. It's quite logical when you think about it. The trapeziums all join up and there's an extra bit at the end. They've got to start somewhere, and that's where the extra one comes from. In the formula, if you're looking at a formula sheet in front of you, that's why y starts at y0 rather than starting at y1. And how nice was that? All the values are there, and the particularly nice thing is you only had to type in the equation of the function once. I've seen students use the navigation key, so once they've typed it in once, use the navigation key to find their value, change that, press equals again, re-evaluate the answer. But equally I've seen students make mistakes with that. So if you have got a large number to work out, maybe give this a go, see if you find it useful. But as always, no surprises here guys, I have a puzzle to try and encourage you to get used to this and how it works. So I'm going to type in a function, delete my old function there, so it's all deleted. Now this function isn't that complicated. It's only seeming complicated to me right now because I writ it on a piece of paper which I can't see in front of me, so I'm having to use my login to work out what it is, and it's okay, I've remembered. Okay, it's in. I'm going to help you out by telling you the start intervals and the steps. I'm going to start this one at 0. I'm going to end this one at 10. And I'm going to use a step size of 1. And here is my table. That's the end. Nothing magic. Think about what functions you know. See if you can get this. There's going to be more than one answer. But bear in mind I only typed in something that was simple. Hopefully that will limit the number of hours you spend trying to find this one. Once you do find something, answers in the comments.